Stratton's matrix multiplication is another way to do matrix multiplication. So we have, let's say, some n by n matrix. Usually any computation of such a form, matrix multiplication, is going to take O of n cube time. And here, that is, it uses 8 multiplication calls, but using Stratton's matrix multiplication, we are reducing it from 8 to 7. Though it might look as very small change, but it's a very matrix multiplication holds a lot of importance in uh, neural networks, where we have large amount of matrices. Let's say if we take CNN networks, CNN and not networks, CNN model, then image processing, all those require a lot of computation. So this efficiency from 8 to 7 recursive calls, this has a lot of impact in the processes. So here we will divide each matrix into 4 submatrices. We compute 7 intermediate matrices, P1 to P7, and then we combine them to form the final result. Though there is a minor, uh, looks to be a minor change in the complexity, but it is impacting it in a major way. We split matrix A and B into 4 submatrices each, and then we compute 7 products P1 to P7 using combinations of submatrices, and we use these products to construct the result matrix. So consider, so whatever is my matrix, I will divide it into 4 subparts like this, and then here I am calculating P1 will be nothing but A into F minus H. P3 will be C plus D into E. P5 will be A plus D into E plus H. P7 will be A minus C into E plus F. So like this I calculate P2, P4, P6 also. And this is my resultant matrix. So in the resultant matrix, it will be nothing but P5 plus P4 minus P2 plus P6. Here it will be P3 plus P4. Here it will be P1 plus P2. P1 into P5 minus P3 into P7. So like this I am getting the resultant matrix here. I'll show one example also, one programming example. So here it is faster than the traditional method. It's useful in image processing, scientific computing. And the disadvantage is it has so many additions and subtractions. Sometimes numerical stability may be affected, and it's not needed for small matrices. I will So this is the program for Strassen's multiplication. I have written a simple code here to add matrix A and B. So this basically adds a matrix, and this is to subtract a matrix. So for that I have defined functions, and now this is the whole Strassen's multiplication. See, first of all I split the array into 4 equal halves here. I calculate what is the middle number, and then I calculate 4 equal halves here. Then call 7 recursive multiplications as we saw. Compute P1 to P7. Once I do that, I have to compute my final result using C11, C12, C21, C22. This is going to be my final result. So here it is, see, as you can see, it's P1 plus P4 minus P5 plus P7. So like this, I compute what is there in the quadrant, and then I can combine that C11, all these into one, put together as one C array. Once I do that, I return this C array and then print the result. I will also share the notebook related to this.